Okay, so this lesson we're going to look at triangles and the inequalities that are formed by it. And what we have to do is we have to do an algebra review of inequalities as part of this. So in doing this, I'm going to go over some things that are pretty familiar, but again, you might take a little bit of extra time to come up with the information, okay? So just a reminder of what these look like. When we have a greater than, the symbol looks like this. And so when we do x is greater than 5, your graph is going to be on a number line, not on, like we did before. It's not an x-y axis, it's just an x-axis. You only have one variable. So that's why when a greater than, we're going to do an open dot, because it doesn't include it. It includes all the numbers larger than 5, but not 5 itself. Greater than or equal to, if we have a, like for instance, x is greater than or equal to -2, again, you start at 0, you go to -2, that's going to be a solid dot on -2, and every number above it, so it's shaded to the right because of that. So when it does not have the or equal to, it's open. When it does have the or equal to, it closes it off, and then you shade it because it includes all these other infinite number of numbers to the side of it. Less than goes the other direction. It points to the left, saying that the number on the left is smaller than the number on the right. So if we do a less than, if we have x is less than 10, on our number line, I'll go by 5s. It would be an open dot on 10 and to the right, to the left, excuse me. Shaded over that way. And then a less than or equal to, all it does is close in that dot. So x less than or equal to 3. There's 0, 1, 2, 3. Put a closed dot on 3 and go to the left, because it includes all the numbers that are smaller than it. There's an infinite number of those. This between notation you may or may not remember, but it's something that we're going to see at times. It's where we have something like this, where it would be x is less than in two directions, two of them. So if I have, for instance, a 1 and a 6 here, this is just saying this is all the numbers between 1 and 6. If you read it from the x, it's x is greater than 1 and x is less than 6. Numbers greater than 1, less than 6. What that looks like on the number line, here's 1, here's 6. We have an open dot at 1, open dot at 6, and everything in between. If all we did was made one of these or equal to, like this is less than or equal to 6, we would just fill in that dot on the 6, but leave the 1 open because it's not or equal to. So this notation just means pick all those numbers between the two given to you. Let's do some examples. Use these to guide our work. So this first one here, when you're solving inequalities, you want to first of all, let's see here, move that back. The first thing you want to do on these is you want to first use the steps like an equation. Adding to both sides, dividing on both sides, subtracting from both sides, those are all the sorts of steps you do here. The only thing you have to remember, the only exception to the same rules as the equation is if you multiply or divide by a negative. reverse the inequality. Alright, what that means, the inequality symbol, because this order makes a difference, which is larger, 6 or -2? Which is larger, 6 or -2?
6.
6 is larger, right? If you multiply them both by -1, I get -6 and +2. Now which one's larger? Well, the 2 is. By multiplying by -1, less than and greater than gets switched. So that's why if you multiply or divide by a negative, you must reverse the inequality symbol. That's the one exception rule that you gotta remember here. So here, when we solve something like this, we just subtract 5 from both sides. So if we subtract 5, we get 3x is less than 30. There we go. 3x is less than 30. And divide by 3, and you get x is less than 10. It's not division that does it. Leave the inequality the same here. It's if you were to divide by a negative. So I get my graph, let me go by 5s here. Open dot on 10 and to the left. X is less than 10. This one, I'm going to go ahead and add 4 to both sides, so you get 28 is less than or equal to 7x. Now I want to divide by 7 on both sides to get rid of that 7. So dividing by 7 will give me a 4 here, and the x will be by itself. Now read it from the x. This says 4 is less than or equal to x. If you read it from the x, it reads as x is greater than or equal to 4. So just a reminder, if I want to read it from the x here, the inequality would end up swapping directions because the greater than part is next to the x. So some people like to put the x on the left. That's helpful. And that's when you'd also reverse it and put greater than or equal to 4. Is because I've swapped the two sides, the inequality has to follow. All right, let's do this last one. We want to subtract 8 from both sides first. So -6x is less than 12. Divide both sides by -6. Dividing by a negative reverses my inequality, makes it a greater than. Divide 12 by -6, you get -2. So at -2, we just put an open dot and shade to the right for the greater than. So that's just a review of how you do the inequalities, solve them, and graph them, which is a little bit of algebra review. One of the things we'll do regularly is review those topics, okay? Now we will do these in these inequality problems. You'll actually be applying this. All right, let's go down to this chart here. Here's some theorems that we're going to use. The angle side relationships. In a triangle, the larger angle is opposite the larger side. So if I've got a triangle here, you see how this angle here is the largest angle? This is the largest side. It's opposite it. That's a property that we're going to use a lot, is if you have 3 different angles, if you look at the size of the angles, sides of the angles are going to be proportional to the lengths of the sides opposite them. Right? triangle inequality theorem. This is where you take the sum of any two sides of a triangle. It's greater than, so here's where we're using our inequalities, greater than the third side. This was the exploration you were doing. These two sides have to add up to more than that side, otherwise it wouldn't fit, it wouldn't give it a point to the triangle. So they can't be equal to it, they have to be greater than it. Okay, so if we had ones that are really close, it'd be a really tiny one like this, but they still have to be greater, and that will give it a point to it. And lastly, the last theorem we're going to use is the hinge theorem. If two sides of a triangle are congruent to two sides of another triangle, then the larger third side is opposite the larger angle. Okay, so if you've got two triangles, this is one of the examples you were looking at. All right, and so this side is congruent to, let's say, this side. And these two sides are congruent. This side becomes larger because this angle is larger. So if you're gonna make that angle larger, it's gonna make the side longer. All right, let's do some examples of this. Which of the following are possible sides of a triangle? Now what we do to do this problem is you look at them and you say, this is the way to really figure this out. The smallest two, when you add them together, have to be larger than the biggest one. The other one's gonna fall into place. I mean, in essence, it's gotta be 4 plus 6, is that larger than 7? And the answer is yes. Because the other two are naturally gonna be the case. If I did 4 plus 7, they have to be larger than 6, and 7 plus 6 would have to be larger than 4. I mean, every pair, when you add them up, have to be larger than the other one. The only one you really have to check is the smaller two. If the smaller two sides add up to more than the larger side, it's a triangle. So this would be yes, it is a triangle. Look at this next one. If you add the two smaller ones, is it larger than the third? No. 2 plus 5 is not greater than. Okay, so if I put greater than, it is not greater than the 10. You can't have a triangle with two sides that are 2 and 5 and the other side 10. So the answer would be no. That's all you have to check. And this last one here, take the two smaller ones. The two smaller ones add up to more than the third one. That would be a yes. So we get that one as a triangle. So we put yes on this one. All right, let's do this last one here. This one it can be the most confusing, so let's make sure we organize our work with it. It says if we have two sides of a triangle that are 30 and 36, what range of values could the third side be? So we don't know the third side. Let's say that our three sides are going to be 30, 36, and x. Well, our theorem tells us that 30 plus 36 has to be greater than x. You add up two sides, it's got to be greater than the third. So if you read this, this means that 66 has to be greater than x. Or x is less than 66. It's got to be smaller than 66, otherwise it wouldn't fit. Let's take two other sides. You'd have to do Let's do 30 plus x greater than 36. Subtract 30 from both sides. This is where we learned our rules for solving these inequalities. Subtract 30 from both sides and you get x is greater than 6. Okay? And let's do the last one. We did these two added, the first and the last. Now let's do these two. Just look at this one for just a moment. X plus 36 greater than 30. Is there any number possible to add 36 to it and not have it be greater than 30? It's not possible, right? So we need to, this one is always true. Because sides of a triangle are always positive, you can't make it a negative. And so this is always true. So this gives me my range. Read it from the x. X has to be less than 66 and greater than 6. This is that between notation that allows you to figure out that the value is between 6 and 66. Any questions on that?